Okay, we're going to review learning to solve systems of equations, systems of linear equations by substitution and the linear combination method. Substitution and the linear combination method. Now, page 42 of the Algebra 1 book says, to be able to do the order of operations, you can only have one variable or one name. Now, there's a problem here because we have two names, x and y. So what we need to do is name one in terms of the other and use substitution to get it down to one name. So in the second equation, 5x plus y, since it tells us what y is equal to in the first equation, we're going to replace that y in the second equation with a 2x, with what it's equal to. And so then we're going to have 5x plus that 2x equal 35. So we made a substitution. We replaced y in the second equation with what it said it was equal to in the first equation. That gets us down to one name, x. So now we can solve using the order of operations. You understand that? So to solve, we're going to combine like terms. 5x and 2x is 7x is equal to 35. Now we're going to undo multiplication by division, and we get x is equal to 5. Now, we want the y that goes with it, so we're going to plug it in. So we're going to have y is equal to 2 times, crammed on there is multiply, what x was 5, and so y is equal to 10. And then we want to talk about the directions and the definition or the term. So let's talk about that. It said to solve the system. So we need to know what that means. So let's define it. On page 130 of the Algebra book, it says that a solution to a system of linear equations is the one x, y that makes them both true, which would be, graphically speaking, and this is just a rough, I'm not even trying to graph these right, which would be the point of intersection in the graph, if you graphed them, right? The solution to a system of linear equations is the one point xy that makes them both true, which would be the point of intersection in the graph if you were to solve graphically, okay? Any questions on that? Okay. Number two, we have a system of equations, y equal x plus 4 and 3x plus y equal 48. We do have an equation where there's an isolated variable. It tells us what it's equal to. So we have y in terms of x. That means we can go to the other equation where the y is and put that x stuff in its place. So where the y was, we put x plus 4. Understand that? And then everything else goes back. We still had the 3x, and we equal 48. So by substitution, we're down to one variable x. So now we can solve using the order of operations. To solve, we will begin by combining like terms. 3x plus x is 4x plus 4 equal 48. And now we're going to undo. We have multiplication and addition. We undo addition by subtraction. We have 4x equal 44. Now we're going to undo multiplication by division, and we get x is equal to 11. Now again, what are we looking for? What are we trying to do? Solve the system. We want the solution to the system. The solution to the system is the one x, y that makes them both true, which would be the point of intersection in the graph. So the y. To get the y, we can take what we got for x and plug it in over here. y is equal to x, which is 11 plus 4. So y is equal to 15. Any questions on number 2? Solving a system of linear equations by the substitution method. Okay? Any questions? Okay? Number 3. Number 3, again, what we're looking for is a place where it has a variable all by itself. This time we have x in terms of y. So we're going to come to the first equation where the x was, and we're going to put that y stuff in its place. So we're going to replace that x with y minus 2. Understand how we did that? And then we still have the rest of that equation plus y equal 8. This time we're solving for y first. We're going to combine like terms. Y plus y is 2y. That means you're smart, right? 2 y's you are. 2 y's you be. I see you are 2 y's for me anyway. So we got 2 y's minus 2 equal 8. And so now we're going to undo subtraction by addition. We get 2y equal 10. Undo multiplication by division, and we get y equal 5. Remember that the solution to a system is the one x, y that makes them both true, and this time we found the y first, so we want to make sure we put it in the right position. And we need to find the x, so we're going to take that 5 and put it in place of y. So we get x equal y, which is 5 minus 2, and so we get x is equal to 3. And so the solution to the system of linear equations is 3, 5. And if we graphed them both on the same grid, that's where they would intersect, right? That would be that point common to both figures. Any questions on number 3? Okay. Number 4. Number 4, we have an isolated y. It says it's equal to this x stuff. So we're going to put that x stuff in place of that y right there, right? Now we got to kind of be careful. So we're going to replace the y with 3x plus 5. Let everybody get that written down, and then we'll talk about it. I'm going to do this in color. The 2 that's crammed on that y means to multiply, right? Now what's going on? We've got a higher operation multiplication that's going to be happening to a lower operation addition. When a higher hits a lower, you do what? What happens when a higher operation hits a lower operation? You put the lower operation in parentheses. See, we have a higher operation multiplication happening to a lower operation addition, so we have to put the lower operation addition in parentheses. Don't forget to do that. And then we still have the 3x plus on this side, and we still have the equal 100 on that side. Everybody see how we inserted the 3x plus 5 in place of y, and we stuck it in parentheses. To solve, what would we do first to simplify? Distribute. So 2 times 3x is 6x, and 2 times 5 is 10, and it's positive, so we put a plus. So 3x plus 6x plus 10 equal 100. What can we do now to simplify? Combine like terms. So 9x plus 10 equal 100. And so now it's time to undo. We're going to undo addition by subtraction. We get 9x is equal to 90. Undo multiplication by division, and we get x is equal to 10. The solution to a system is the one xy that makes them both true. We need the y. So we're going to plug that back in. We get y equal 3. Crammed on there means multiply, so times the x, which is 10 plus 5. And so we get y equal 30 plus 5. So y equal 35. Any questions on number 4? Okay. Number 5 is no different. It just has a fraction, and that scares people, but it doesn't have to. We just deal with that fraction. Everybody finish with number 4? Good? All right. Number 5, we find our isolated variable y. We're going to see what it's equal to. We're going to go to the other equation, take out the y, and put that in its place. So we're going to replace that y with 3/4 x plus 3. Now, crammed on that y was a 5 that's being multiplied. So that's going to be a higher operation multiplication that's happening to a lower operation addition. So we're going to put that lower operation addition in parentheses and multiply. Creates a distributive property. In front of that, we had 2x plus, and after that, we had equal 38. So now we're down to only x's, so now we can use the order of operations. We're going to distribute first. You could think of that as being over 1. So you're going to have 2x plus 15 over 4x. Everybody comfortable with the 15 over 4x? Plus 5 times 3 is 15 is equal to 38. Now some of you were working ahead here, but I want you to make sure you pay attention to this part because some people forget what to do. What would we do next according to the order of operations? We would combine like terms. But when our like terms involve fractions, then we use a trick. What's our trick? To make there not be any fractions to deal with anymore. You multiply through by the common denominator of every fraction in the whole problem. Now, all the rest of the denominators are 1. The common denominator between 1 and 4 is 4. So we're going to multiply every single term by the common denominator 4 so that there's not any fractions to deal with anymore. Now, this is standard practice in college algebra, so we would expect that you would do it this way. So 4 times 2x is 8x. Now, what's going to happen when the 4 hits the 15 force? The 4's cancel, so you have plus 15x. And then the 4 times the 15 is 60. And then 4 times 38 is 172. Wait, 120 and 32, 152. Whoops. Now there's not any fractions to deal with anymore. So now we're going to combine our like terms. That's what we were fixing to do, but we made them not be fractions first. Now we're going to combine our like terms. 8 of those and 15 of those is 23 of those little x's. Plus 60 is equal to 152. Now we're going to start undoing. Minus 60. 23x is equal to 92. Everybody understand? Undo multiplication by division. X is equal to 4. So it's 4 something. We need the y, so we're going to come over here and plug it in right there. So we're going to have y equal 3/4 times my x of 4 plus 3. Everybody see that? 4's cancel. Y equal 3 plus 3. Y equals 6. And so it's 4/6. Any questions on number 5? So we had a little get rid of the denominator trick in there. That's standard practice in college algebra, so we need to be familiar with that and use it. Okay? Any questions on number 5? Very good. All right, number 6. Number 6, is there an equation that has the y isolated like it was here? No. Now, if I was going to isolate one of them, which one of those two would you choose to isolate? The one with the least amount of junk on it. The second one, right? Isolate the one that's easiest to isolate. So we need to isolate a y. We're going to isolate the y that has the least stuff on it. To isolate that, when we move the 5x to the other side, remembering to change the sign when you cross over, and we have y is equal to 5x minus 11. See how we got that? We just changed it from what? Standard form, except it's got a negative a, to slope-intercept, right? It's kind of sort of standard form to slope-intercept. Now we've got an isolated y. We know what it's equal to. We come to the other equation, and we replace the y with what it's equal to, 5x minus 11. Now the 3 is crammed on there. That's multiplication. Happening to a lower operation, subtraction. When a higher operation hits a lower, you have to put the lower in parentheses, which creates a distributive property situation. We still have the 2x plus in front of that, and we still have the equal 9 on the other side. Let's see how we got there. So now we can solve. The first thing we will do is distribute. 3 times 5x is 15x. And 3 times negative 11 is negative 33. 2x plus and equal 9. We distributed. Now we can combine. Whoops. That's not underlined. It just really looks like it. Combine like terms. And we get 17x minus 33 equal 9. Now we can undo. We have multiplication and subtraction. We undo subtraction first by addition. And we get 17x equal 42. Undo multiplication by division. And we get x is equal to 42 over 17. Because it doesn't divide evenly and it won't reduce. So we leave it improper. And so we're going to have 42 over 17 comma something. So now we need to plug back in. So we're going to plug this in right here. So we're going to have y is equal to 5. And I'm going to put it over 1 times x because x is this fraction. 42 over 17 minus 11. Order of operations says you do which one of those operations first. You multiply before you subtract. So we multiply. 5 times 42 is 210. And 1 times 17 is 17. And I'm going to write this vertically, minus 11 over 1, right? To subtract, what has to be true? You have to have a common denominator, which will be 17. 1 times what is 17? So 11 times 17 is 187. And then 210 seventeenths is still 210 seventeenths. And it was a minus. The name stays the same, seventeenths. 210 of those minus 87 of those would leave 23 of those little seventeenths. So we had a little fraction stuff to deal with there, and there'll be a lot more fraction stuff that eases its way into pre-calculus. But there's a little bit that made its way into that. So sometimes when you have to isolate one and plug it in, it can begin to get a little more challenging. And all answers don't have to be pretty little whole numbers. You know, we can have mixed numerals and fractions and all kinds of weird stuff. I shouldn't call fractions weird because fractions are numbers just like 2s and 3s, and that might hurt their feelings if we say they're weird. But anyway, people tend to not like them, and it's not really their fault. Any questions on 1 through 6? Solving systems of linear equations by substitution. All right. The back side is solving systems by the linear combination method. And let me let you know that many books or authors or teachers would call this the elimination method. Does that have 1 or 2 L's? It has 2, I think. Elimination. Does it have 1 or 2 L's? 1 L. We just make it. So some people call it the elimination method instead of the linear combination method. I call it linear combination because you're combining lines. But when you get into systems of 3 and 4 and 5 and 6, you're not dealing with lines necessarily. So the elimination method is a more extensive approach. Now, the idea of solving by elimination method, I'm going to back up. I'm not going to do number 7 first because it's easier. So we're going to start with number 9. The idea of the elimination method is this. Do not write this down. If I were to add these right now, I would get 7x plus 12y is equal to 50. That doesn't help me because I still have 2 unknowns, x and y. I can't solve. I need to fix it so that when I add it, one of them gets canceled out. That's the whole idea of the elimination method. When I added them as they presently are, nothing got eliminated. It's not going to get eliminated unless these are opposites, right? Additive inverses. So the idea is that we're going to multiply through by whatever it takes to make whatever coefficient we're trying to get rid of opposite. So then we decide, do I want to cancel out my x's or y's? Which one do you want to cancel? If we want to cancel out our y's, then we need to change the 5y and 7y to additive inverses. So we think, what's the smallest thing 5 and 7 will both go into? Like the least common multiple, which would be like the common denominator? 35. And we need to produce a positive that and a negative that. So we're going to multiply through by whatever numbers it takes to change the 5 to a 35 and the 7 to a negative 35, right? So we think 5 times what number out here would give me that 35? Positive 7, right? 7 times what number out here would give me that negative 35? Negative 5. Now, don't try to memorize that these things out here are the same sign or different signs. It depends. The 7 and 5 outside, they could both be negative. They could both be positive, one negative. There's no magic trick to that. When we ask the question 5 times what, that's how we know what goes there. When we ask 7 times what, that's how we know what goes there. What you do to the left, you have to do to the right to balance your equations. So we're going to produce new equations. And do not forget to distribute onto the other portion, right? So 7 times 3x is 21x. 7 times 5y is 35y, and it's positive. And then 7 times the 21 is 147. On the bottom, we're distributing a negative 5. Negative 5 times 4 is negative 20x. Negative 5 times 7 is negative or minus 35y. Negative 5 times 29 is negative 145. So now when I combine them, the y's are going to cancel out because now they're additive inverses. I'm still going to combine using sign rules. 21x minus 20x leaves us with 1x. Those cancel. Equal 147 minus 145 is 2. So I get x equal 2. Now we're still solving a system, right? The solution to a system of linear equations is the one point x, y. Whoops. X is 2. X, y that makes them both true. So we need the y. Now how are we going to get the y? You can take any of the equations you see. You got 4 choices. Why choose the big ones? Choose the little one. I would choose the smallest one, like 3x plus 5y equal 21. We're going to put what we got for x in place of x and solve for y. Just choose the easiest equation to deal with. So we're going to have 3 times my x of 2 plus 5y equal 21. And then we solve for y. You can actually do the 3 times 2 and get a 6. So we get 6 plus 5y equal 21. There's nothing else we can do to simplify, so it's time to undo. We're going to undo the 6 with a negative 6. You get 5y equal 15. Now we're going to undo multiplication by division, and we get y equal 3. If we were to graph those 2 equations, that would be the point of intersection. If we plugged it back into x and y, it would make the top 21 and the bottom 29. Okay. Any questions on solving by the linear combination or the elimination method? We eliminated the y's, solved for the x's, plugged back in. Okay? Everybody good there? All right, let's look at number 10. You want to eliminate your x's or y's? X's. Cool. Good choice. Now, so if we were going to eliminate the x's, we would need to produce additive inverse x's. And we want the least common multiple between 3 and 5, which would be 15. And one of those needs to be positive, and one of those needs to be negative. And so we're going to multiply through by whatever it takes to accomplish that. And so we think, negative 5 times what number will give me a 15? Well, the answer is negative 3. But if you don't know how to get the negative 3, because some people have sign rule trouble, then tell me what to punch in the calculator to make sure you get the right number. 15 divide negative 5. If you want to know what do you multiply negative 5 by, and you can't think it up in your head, then divide on your calculator, and it's going to tell you, right? 15 divided negative 5 is, what is it? Negative 3. Negative 3. And then negative 3 times what is going to give us a negative 15? A positive 5. Again, if you're prone to making mistakes, then do the division on your calculator so you don't make mistakes. So we got a negative 3 and we got a positive 5. So now we're going to distribute a bunch of signs going on. Negative times negative is positive 15x. Negative times negative is positive 21y. Negative times negative is positive 123. Positive times negative, negative 15x. Positive times positive, positive 25y. Positive times positive, 15. Understand that? Watch those signs. They'll eat you up on this stuff. We just created additive inverse x's. So now when we cancel, we will have eliminated, hence the elimination method, eliminated the x's. 21 and 25 is 46y. It's equal to 123 and 15 is 138. Undo multiplication by division to solve for y. Y equal 3. We need the x. We'll take one equation. The simplest looking one of all to me is that one. So I'm going to take it. Negative 3x plus 5y equal 3. It doesn't matter which one you choose. I'm going to put the y in place of y and solve for x. Negative 3x plus 5 times the y of 3 is equal to 3. We can do multiplication, so we do. Negative 3x plus 15 is equal to 3. There's nothing else we can do to simplify. The variable x is not on both sides, so we're going to undo addition by subtraction. We're going to get negative 3x equal negative 12. Now we undo multiplication by division. When you divide with the same sign, the answer is positive, and so we get x equal 4. So the solution to that system is 4, 3. That would again be the point of intersection in the graph if you graphed them both. Any questions on the elimination method of solving? Our next lesson, there's going to be 3 variables, x, y, and z, and it's going to take 3 equations to solve. It's going to be a little more complex. So we'll have a triple pair. We won't have an ordered pair of 2, we'll have an ordered pair of 3, x, comma, y, comma, z. So this is leading into something bigger, just so you know. Don't just study this for this lesson, study it so that you can learn enough to apply it to something bigger, okay? Any questions on 9 and 10? All right, on 9 and 10, we learned how to deal with it when it was a little more complex. Number 7, which ones are you going to choose to eliminate? The ones that are already additive inverses, right? They're already additive inverses, so we can already combine and eliminate the x's. And so we get 12y equal 24. You don't have to go through all that because the x's are already additive inverses. So we're going to divide by 12 and get y is equal to 2. We know that we want an ordered pair something 2. So we take one of the original equations, 3x plus 5y equal 19. We're going to take our y and put it in place of y. So we have 3x plus 5 times y of 2 equal 19. And then we could solve for x. Everybody understand that? That's a 19 over there. So we can do that multiplication, so we get 3x plus 10 equal 19. Start undoing, subtract 10, 3x equal 9. Undo multiplication by division, x equal 3. And so the solution is 3, 2. Since we already have a variable that can be eliminated, we don't go through all of that. We just go ahead and eliminate it. Okay? On number 8, is there a variable that can already be eliminated? Yes, the y's. So we're not going to go through all that multiplying stuff. We've already got what we need, a variable that's additive inverses. So we're going to go ahead and combine, and those will cancel, and we're going to get 6x is equal to 30. When you add or subtract with different signs, subtract and take the larger sign. Undo multiplication by division, x equal 5. The solution is 5 something. So we're going to take one of the original equations. I'll just take the 2x minus 3y equal negative 14. We're going to take the x and plug it in place of x and solve for y. Pretty good so far? So we're going to have 2 times that x of 5 minus 3y is equal to negative 14. And then we can start, well, we're going to do first. And we can do the 2 times 5 and get 10 minus 3y equal negative 14. Now we can start undoing the 10 with a minus 10. And we get minus or negative 3y is equal to, when you add or subtract with the same sign, you add and take the common sign, negative 24. And then we're going to undo multiplication by division. Divide with the same sign, answers positive 8. And so the solution is 5, 8. So that's a review of solving a system of linear equations by substitution on the front and the elimination method on the back. Any questions on that? Our next lesson, we will be solving with 3 variables, x, y, and z. And we'll get a triple set, x, comma, y, comma, z. Okay? All right, appreciate your